what's up, homies? Today, we are going to talk about properties of logarithms. And I know you're thinking, but Barton, I learned this last year. That's great. You're going to do it again. I can't wait to see how great you are at expanding and condensing logs. So those are the two things we're going to go over today. How to expand and condense logs. Expand, that's the English word for make stuff bigger. Condense, that's the English word for make stuff smaller. And we're going to do that to logarithms. And I already know what you're thinking. You're going to go, Barton, I don't know the properties of logs. That's why I wrote them down for you. So let's just go over the 3 properties of logs that you're really going to need to know today. And then we'll do a couple of examples just to get you oriented to what you're doing. So this first one is called the product property. Let me just write that down, property, there we go. There's no way that's spelled right, is it? Absolutely no way. I apologize. Don't tell your English teachers. I can't spell check the stuff I handwrite. So this is the product property. That's because you get a product. These X and Y's are being multiplied in here. So what the product property says is that if we have 2 logarithms with the same base, and that's what that little b is. This b might be a number when you're doing your problems. It might be a variable. It might not even be there. But you have to make sure that that thing, that little subscript, matches. Otherwise, none of these properties are allowed to happen, except this one, because there's only one log, but c'est la vie. So if you have 2 logarithms with matching bases, and those 2 logs are being added together, what you are allowed to do is take this argument, stick it inside that log, and multiply it to the argument that's already there. So if we do that, this log goes away, and then inside the log we have X and Y being multiplied. Just because I'm explaining it from left to right doesn't mean you can't go backwards. If you are going this way on any of these properties, you are condensing. You're making it more small, right? We have 2 logs here, you have 1 log there. You condense that bad boy. If you go the other direction though, if you go this way on any of these, you are expanding our logs. Cool. So the first one says that if we are adding 2 logs together with the same base, we can take the arguments and multiply them together inside 1 log, and that log's base is the same as the original base. Now, because we have an adding property, we're going to have a subtracting property, and because subtracting is the opposite of adding, we're going to do the opposite of multiplying. We're going to divide. So if you have log base b of x minus log base b of y, you can turn that into log base b of x divided by y. A handy hint that you should know is any logs that have a minus in front of them, negative logs, hold on, I'm trying to spell and teach at the same time, and you know what they say about people who spell and teach at the same time. If you have a negative log, its argument will just always go on the denominator. All right, so the y would go down here. That's, actually, we'll see an example in a couple. So hang on to that idea. Our last one here, this is called the power property. This one says that if you have a coefficient in front of your log, so this c is a constant. It could be 7, it could be 3, it could be x. It doesn't really matter. But if you have something outside the logarithm being multiplied to the logarithm, what you're allowed to do is take that coefficient, bring it inside the argument, and turn it into an exponent on your argument. Okay? So there's our 3 properties. Product property, quotient property, because, dividing, the answer of a division problem is a quotient. And then power property, because we turn it into a power. All right, let's go do some examples. So we want to expand these logarithms And that means we are going to take these properties, whoops, sorry, other way. We're gonna go that way. We're gonna take these condensed ones and split them up into multiple things. So the first thing I see in this log here is I have x to the fourth, and because it's just sitting next to this y to the fifth, that means they're being multiplied together. So what I'm going to do is I'm going to use our product property to take two things that are being multiplied together and split them into two separate logarithms. And let me clear that page just so if I need to write on it later. So the way we do that is we keep the log the same. So we're going to have log base 8 of something. And the product property says that the multiplying turns into a plus sign. So we're going to have plus another log base 8 with an argument. Now we just take these two arguments and put them in their own logs. So this will be x to the fourth, and this will be, whoops, excuse me, that one will be y to the fifth. Now this is not as expanded as it could be because our arguments have exponents on them. We could use our product property right here to take this exponent and move it in front of our logarithm. So we're going to take the 4 and throw it in front of that log. We're going to take the 5 and throw it in front of that log. So we're going to have 4 log base 8 of x plus 5 log base 8 of y. And this is as expanded as we can turn this logarithm into. Now I know what you're thinking. You're thinking, Mr. Barton, why the heck would I ever want to do this? And the answer is you probably won't. To be honest, unless you go into engineering or a STEM field, so science, technology, math, engineering, stuff like that, you're probably not going to use this. But it makes it so we can simplify some stuff sometimes. There's a whole bunch of really premeditated questions that exist that demonstrate these properties really well. You're like, oh, look how nice that is, right? But you know, logs happen a lot. Anytime you don't have something that's in a straight line, you can hit it with a log and it'll probably turn into a straight line. Logs are cool that way, but I digress. All right, let's look at this second one here. This one's a doozy. I took this out of your pre-cal book, and that book really doesn't mess around, right? They give you problems that are gonna put hair on your butt. Like, what, you're gonna be a man. Even if you were born a woman, you're gonna be a man when you're done solving problems out of that book. It's a tough one. They've got some sneaky ones. So let's look at this one. The first thing we want to do is deal with this radical, because we don't have, do you see any radicals on this properties page? I don't. So what we want to do is we want to turn this radical into something that's useful to us that we can use. So one way you can write square roots. Square roots are the same thing as having something to the 1/2 power. So we're going to rewrite this with a 1/2 exponent instead of the radical. So we have the natural log, and for those of us who forgot, log base e, and this is Euler's number. It's 2.714 something. This shows up so often they gave it its own special log, and it's called a natural log, which is ln. So they don't write the e here, but you can tell it's log base e just because it says ln instead of log. So this is a natural log, the base is e. So this is ln, and I'm gonna, here, let's do a bracket for the log. So this is gonna contain the whole argument, and I'm gonna just split this up a little bit, right? So this is gonna be x squared times x plus 2, and then this whole thing is to the 1/2 power, and then it's inside the logarithm. Cool. So what we're gonna do is we're going to distribute our 1/2 power onto the two things in here. Are we gonna do that? Let me think about that for a half sec. How do I pause recording? All right, I actually lied to you. We could do this. This is a totally legal math move. We're using properties of exponents here. However, let's not make our lives harder than it has to be. This is an exponent. Let's just use the power property to turn into a coefficient. So we have 1/2 the natural log of x squared times x plus 2, like that. Perfect. Now, inside our logarithm, we have two things multiplied together. We have an x squared being multiplied to an x plus 2. So now we can hit this thing with our product property, this one right here, to turn this into two logs being added together. So this chunk is going to get replaced. This 1/2 is going to stay on the outside. So we have 1/2. We're going to split this up into two logs. We're going to have ln of x squared, and we're going to have plus ln of x plus 2. All right. Now let's get rid of this 1/2 here. So we're going to turn that into a coefficient on its log. So we have 1/2 times 2 ln of x plus ln of x plus 2. And now we can just distribute this 1/2 on there. If we distribute the 1/2 here, it would have still worked out the same way. So distributing 1/2 times 2 is 1. So this is 1 ln x plus 1/2 ln x plus 2. Some of you guys are probably screaming at your screen right now, but Mr. Barton, what about this x plus 2? Let's go look at our properties really quick. Do you see on here a property that has log base b of x plus y, where the plus sign is inside the logarithm? Well, here's a plus sign, but it's not in the log, it's between the logs. There's no adding here, there's no adding here, there's no adding here. This thing cannot be condensed or expanded. This is unchangeable. This has to stay the way it is. So if you have adding or subtracting inside your logarithm like this, there's nothing you can do about it. This ln of x plus 2 is stuck the way it is. So this is our expanded logs. All right, one more. Oh, what a doozy. All right, let's start by changing this radical into an exponent like we did here. So I'm going to keep my log base 8. Is it okay if I erase this? Yes, Mr. Barton. Okay, cool, thanks. I just want to make sure, here, let's just get rid of everything. That way we can see everything clearly. So we're going to turn this radical into an exponent. So let's keep everything else the same. So I still have a log base 8. Got a big set of parentheses with a 3 outside. Got a y squared on the bottom. Now our root, our cube root here, a third root turns into a 1/3 power. The denominator for this should match whatever the index of your root is, or the root number. I've heard it called both things. So because there's a 3 there, it turns into 1 over whatever that number is. So this is going to be x to the 1/3 power. We could go ahead and distribute this 3 to the exponents here. Let's do it that way on this one, just so you could see what happens, because we took this 3 all the way out in front on this problem. So let's do it a different way on this one. Let's go ahead and distribute our 3 to all of our exponents. So we have log base 8 of 1/3 times 3 is 1, so that's nice. We have x to the first power on top, and then 3 times 2 on the bottom is going to be 6, like that. Cool. All right, now we can use our quotient property to separate these. So this is going to be log base 8 of x. Now because this is on the bottom, it goes into the second logarithm, and that log gets a minus. Anything on the bottom, when you separate it, its log should be negative. So we're going to have negative log same base of y to the power of 6. And now we have an exponent inside our logarithm, so we need to move that thing in front of this logarithm. So our final answer is going to be log base 8 of x minus 6 log base 8 of y. We're gravy, we're Gucci, we're coolin'. All right, now let's condense some logs. So now we are just going the opposite direction. Before, we started with the condensed log and went this way. Now they're going to give us these expanded logs, and they want us to make them smaller and nicer to look at. All right, so let's look at these, and there's kind of a special order you have to do these in. The first thing you want to start with is getting rid of all of these coefficients by turning them into exponents. So this 2 is going to go there and square that whole thing. This 3 is going to come here and cube that whole thing, and I'll work on that with you. And then this one doesn't have a coefficient, so let's not trip. So this will be log base 5 of 2t squared plus log base 5 of 5t squared to the third minus log base 5 of t cubed. Okay, cool. We can actually simplify these pretty easy. You know how to do 2t squared. That's just 2t times 2t. So 2 times 2 is 4, and t times t is t squared. So let's simplify that. This is log base 5 of 4t squared plus log base 5. We'll cube this. So this is going to be 5t squared times 5t squared times 5t squared. So 5 times 5 times 5 is 125. And then t squared times t squared times t squared. When we multiply variables, we add their exponents. So 2 plus 2 plus 2 is 6. So t to the 6th, bring this thing down. Log base 5 of t cubed. Now we just have a bunch of logs with the same base being added and subtracted. So now we're going to use our product and quotient properties to condense them. So these two are being added. That means its argument and its argument are going to be multiplied together. So we're going to have log base 5 of 4 times 125 is 500. And then t squared times t to the 6th, add their exponents, is t to the 8th. Now this one is being subtracted, so we take its argument and we're just going to put it in the denominator of the new argument. So t to the 3rd. Okay. So this is condensed, but we can simplify a little bit. T to the 8th over t to the 3rd, we can simplify that. So that's like having 8 t's on top, right? T, 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 t over 3 t's. So this t cancels that t cancels that t cancels that t. Bob's your uncle. We've got 5 left. So this is log base 5. Those 3 cancel with 3 of those and leave us 5 over 500 t to the 5th. Good? Me gusta. I love math. It's so fun. You should say that out loud. I bet you'll convince yourself by the end of the class. Not like today's lesson class, but by the end of the semester, you guys are like, man, I really do love math. All right, so that's our log all condensed. Erase. Let's go do the second example. So again, when you are condensing, you want to start by turning your coefficients into exponents. So this 4 is going to turn into an exponent there. This 3 is going to turn into an exponent here. So we're going to have log base 5 of 2t to the 4th minus log base 5 of t squared cubed minus log base 5 of t to the 5th. All right, now we need to simplify these exponents. So this is 2t times itself 4 times. So 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 again is 16. So this will be log base 5 of 16. And then t to the 4th power is just t to the 4th power. Minus, when you have a power to a power like this, t squared to the 3rd, all you have to do is multiply the exponents together. So 2 times 3 is 6. So this will be log base 5 of t to the 6th minus log base 5 of t to the 5th. All right, now we have just logs being added and subtracted together, no coefficients. So we're going to use our product and quotient properties to rewrite this. So we're going to have log base 5 because that's the matching logarithm for all of these. This logarithm is positive, so its argument goes on top of the fraction. So we're going to have 16t to the fourth. This log is negative, so its argument goes on the denominator, t to the sixth. This log is negative, so its argument also goes on the bottom, t to the fifth, and these things are just being multiplied together. Now we just have to clean this up a little bit and we're all set. So this is log base 5 of, we don't have any coefficients to do anything with the 16, so the 16 will stay on the top. 4 of these t's cancel 4 of these 11 total, so we'll get rid of that 5, turn into a 1. So I have 7 total on the bottom, so that'll be t to the 7th down there. And then this is all condensed. That's our answer. And that's it. That's all you have to do today. Congratulations, you guys are now masters of expanding and condensing logs. But like every great master, you have to practice, right? Da Vinci didn't get great at painting by not painting. The greats were great because they paint a lot, right? You gotta go paint something. So lucky for you, I have included homework with this assignment where you can go paint and practice your logarithms. If you guys have questions as normal, feel free to ask, or just bottle that stuff up until it becomes an issue and then let it all come exploding out at once. That's fine too. That's how most people deal with their problems. It's not healthy, but it's how they do it. See you next video.